folks, this is a lesson on density, which is the first lesson of the P6 topic. This is about how we calculate density. There'll be a different video that's about how we measure density, because that's one of the required practicals for the AQA GCSE. So let's start off with the equation for calculating density. So density equals mass divided by volume. Okay. We measure mass in kilograms. We measure volume in meters cubed. So density is measured in kilograms per meter cubed. Now, sometimes we do measure slightly differently. This is the unit that we use most of the time, and it's the units that we should really use. But sometimes we use mass in grams and volume in centimetres cubed. So therefore we end up with a unit of grams per centimetre cubed. A little bit later on, I'll explain about how we convert our units. So let's just think about this and what we know. So let's think about mass to start off with. Okay, so how do we measure mass? We measure mass using a balance. A mass is a measurement of how much matter there is in something, how much stuff it makes up. Okay, volume you might already know from maths, but volume is the space that something takes up. So if we think about what we already know, we can have length, which is in one dimension. We can have area, which is in kind of 2 dimensions. So we would do the length times the width. And we can have volume, which is in 3 dimensions. So we would have the length times the width times the height. And so this is for a 3-dimensional shape. So for length, we would have it in meters. For area, we've got length times width, so it would be meters squared. And for volume, we have length times width times height, so it is meters cubed. So we would approach these calculations in the same way that we would for any other calculations. We would write out the equation. So something that's important for this as well is that you need to learn this equation. Okay, you need to learn it off by heart. It's one of the ones they expect you to be able to recall in the exam. So you would read through your question, write out the equation, substitute in the values that you've got, and then calculate. So now I have some questions that we're going to have a go at. The booklets that you've got now, or the pages that you've been sent, have now got these math skills sections in them, and it goes through step by step of how you can answer the calculations. So always go back to this. If you're a bit stuck and you're not sure what to do, if you go back to this, you can have a look and you can try and work through each step to answer the calculation questions. So I'm going to read the question out and highlight it, and then if you pause, try and answer the question yourself, play the video again, and then you can see what the answer is. So question 1, convert the following to centimetres cubed. So we have 100 millilitres and 2 litres. So 2 bits of important information to remind you of at this point. 1 centimetre cubed is 1 millilitre. And in 1 litre is 1,000 millilitres, not 100. Okay, so using this, try and answer this question. If 1 centimetre cubed is 1 millilitre, then 100 millilitres is 100 centimetres cubed. 2 litres, first of all we need to put it into millilitres. So if 1 millilitre is 1,000, if 1 litre is 1,000 millilitres, 2 litres is 2,000 millilitres, and 1 millilitre is 1 centimetre cubed, so 2,000 millilitres is 2,000 centimetres cubed. A block is found to have a mass of 0.84 kilograms and a volume of 3 metres cubed. What is its density in kilograms per metre cubed? So it's given the equation here, so use the steps to fill this in using the data. So the mass is the bit that's on the top, and here we've highlighted mass is 0.84 kilograms, and that's divided by the volume, which here it tells us is 3 metres cubed. So if we get our calculator and we do 0.84 divided by 3, then our answer is 0.28 kilograms per metre cubed. The block below has a mass of 2,400 grams. And then on the diagram it gives us some information: 5 centimetres, 20 centimetres and 10 centimetres. Calculate its volume in centimetres cubed. Volume equals length times width times height. So we have the length here is 20 centimetres, the width is 10 centimetres, and the height is 5 centimetres. So if we get our calculator, 20 times 10 times 5 is 1,000 centimetres cubed. Now it's asked us to calculate its density in grams per centimetre cubed. So we've got the equation again. Density is equal to mass divided by volume. So the mass is going to go in this box, and we've highlighted up here it's 2,400 grams. The volume goes in this box, which we've just worked out is 1,000. So if we do mass divided by volume, so 2,400 divided by 1,000 gives us 2.4 grams per centimetre cubed. A tennis ball has a volume of 150 centimetres cubed and a mass of 58 grams. Calculate the density of the ball in grams per centimetre cubed. So what we're going to do is we're going to write out our equation. Density equals mass divided by volume. So like it's been done for us up here, we're going to do it ourselves here. And then filling in the information here. So the mass is 58 grams and the volume is 150. So 58 divided by 150 is 0.38666666. So we don't need to write all of these numbers. We're going to do it to two significant figures, so 0.3, and then because it's 86, that 6 rounds up. So we have 0.39 grams per centimetre cubed. And for this lesson, we're just going to do this top question. We'll leave the next ones for the next lesson. So an ice cube has the dimensions 3 centimetres by 2 centimetres by 2 centimetres. The mass of the ice cube is 10.8 grams. Calculate the density of the ice in grams per centimetre cubed. So first we need to do the volume, which is length times width times height. And we've got those values up here, 3 times 2 times 2. Which is 12 centimetres cubed. And then for density, we need to write out our equation again, mass divided by volume. Substitute in our values, so the mass is 10.8 grams. The volume we've just worked out is 12. So 10.8 divided by 12 is 0.9. So 0.9 grams per centimetre cubed.